Alright, we're moving on to video, I believe number 5 on QGIS. In this video we're going to be looking at how to kind of do some statistics on your data, or at least set you up so you can do statistics on your data, whether it be looking at multiple years of yield data, looking at multiple years of satellite data, looking at, let's say, your Malik 3 part per million data, which happens to be what we're doing today. So this is a pivot in northwest Kansas. There's I-70 going right by. It's actually in between Oakley and Colby, so where this pivot is at. And what we have for this pivot is a Krieg Malik 3 map that we're going to bring in, display on the whole thing, and then we're going to suck into a grid the mean values for that Malik 3 map. So this could be useful more so if you're wanting to track a field for multiple years at a time. So if you created a grid, it would allow you to track, let's say, grid cell number 22 for 10 years straight, 15 years straight, 100 years straight, and you could do profitability analysis on your field. You could be applying fertilizer through that grid. Essentially, that's what you're kind of doing in a profitability map. Is you'd be applying fertilizer through the grid, applying your seeding rates through the grid, applying basically everything that comes in and goes out of that particular field will be on a grid basis. So essentially we could be farming at a garden scale level with reason to what our equipment can handle. So the first thing we need to do is go ahead and create a grid for this particular pivot. So what we need to do is first create a field boundary so we know where the grid needs to be made. So I've already done that. This one's 301 interstate pivot, 120 acres. It's actually, I think, around 121.9 acres, but I was kind of being lazy that day. So essentially all the fields that I'm helping manage have basically each farmer goes into a 100 category. So farmer number 1 would be start out with 100 and then, or I guess 101, and then move all the way up to however many fields they have. In this particular case, this is the third farmer that I have in my database. So this is his first field that I created. I believe it's the only field at this point in time. But we're going to go ahead and create a grid. I already have it made, but we'll go through how to create a grid using QGIS. It's actually super simple. Probably my favorite thing about QGIS is creating grids. Super simple. So type in grid, if I can spell right. So we're going to come down here to this vector creation tools and click on create grid. And the grid type, we're going to tell it we want it to be a polygon, a rectangle. If you wanted it to be a diamond polygon, you could do that. If you want it to be a hexagon, you can do that. In this case, we're just doing the generic old rectangle. And then we're going to tell it what extent, so the x, y, min, and max coordinates for this particular grid. So we're going to tell it to use our interstate pivot, field 301, for this particular grid. And this is where it gets, the only downfall to this is you have to do a little bit of math on how big you want your grid to be. So it's all reading in decimal degrees. And I need to play around with a little bit, but if we could change this to like feet or something like that, I think if I change something in the master settings, I might be able to do this. But for right now, we're just going to go ahead and put a 1 right there. So, got to think about this. That'd be a tenth, hundredth, thousandth. So it's 1/10,000th of a decimal degree is what we're doing right here. So what that's going to give us is roughly a grid cell. It's actually not going to be square just based off of how the projection is being displayed. The farther north that we go, the more stretched our x coordinate is going to be stretched out. So 1 decimal degree in Alaska is going to be a lot different than 1 decimal degree in, say, like South America near the equator. So if you really wanted to truly get this nailed down to a specific grid size, you'd have to do some math, play around with how to set this up to get whatever grid size you want, just by playing around with your decimal degrees. And once you get it, you could write it down and just apply it to all your grids that you make in that particular area. As long as you're not moving like 100 miles north or 100 miles south, it should be pretty darn close. So we're just going to do 1/10,000th of a decimal degree for the grid size, and that's going to give us something roughly the size of, I believe, about 35 foot by 25 foot, just because we're not at the equator. It's not going to be a perfect square. It'll look like a perfect square because we're using WGS 1984 to project it, because this pivot is actually stretched a little bit sideways. It's more of an ellipse shape if you truly look at it. So we're going to go ahead, and so there's our coordinate system right there. We could go ahead and turn this into a file that we're going to save, but I'll show you why we're not going to save it right away. So we'll push run. I believe it's done. Yep. Alright, so we have our grid out on our pivot, but you can see that it did not, let's move this above, it did not cut it off to our field boundary. So this can be a problem if you need it to be right next to the field boundary. In our case it will be, because we're not going to be applying fertilizer to Interstate 70. So we're going to go ahead and clip this to our field boundary. So just like we did in the past, or actually maybe we haven't done it yet. Anyway, if we haven't done it, I can't remember if we haven't, but you're going to use this little vector overlay. This clip feature is another one that we can use. So we're going to clip our input will be our grid, our overlay layer will be our interstate pivot. So what it's going to do is going to clip our grid essentially to our field boundary. So we can go ahead and push run. This is where you can go ahead and rename it if you truly know this is going to be the grid that you're going to use in the future. So we can name it, we can take and put it onto wherever we want to on our computer. I would strongly suggest that you have a file that's empty that you can put it into, because there's going to be about 5 files that come flying in because it is a shape file. So make sure that you do have a folder that's ready to accept it, so it doesn't create a mess on your computer. It's much harder to go back and try and clean things up than just doing everything nice and clean the first way. That's just my philosophy. So moving on, we're just going to create a temporary layer out of this and click run. So that clipped everything to our field boundary. Looks pretty nice. So we can go ahead and get rid of this grid. And now we're left with our interstate pivot, field boundary, and our grids. Let's go ahead and measure one of these. So this is in northwest Kansas. Let's just zoom out a little bit so we can see where we're at compared to the equator. So we're definitely north of the equator quite a bit. I believe the equator should be down in this area right here. So we're north. Everything's being stretched out in the horizontal direction. So that's why with the projection that we're using, it looks like it's more of an ellipse in shape rather than a perfect circle. So if we wanted it to be a perfect circle, we would choose a different projection. But in this case, I'm not too concerned. All the data is going to be the same in our case. Let's go ahead and measure one of these grids. So again, I have my snapping on. You can see it's snapping on to each corner. So the width is about 28 foot and the height is about 36 foot. So it looks like it's a square on this picture just because of our projection, but it's actually really a little more of a stretched up and down rectangle in reality. And I just used the measuring tool. I didn't tell you, but it's right there. And you can change it to measure in feet, yards, miles, whatever you want it to be. And let's go ahead and get back to your little clicker button. And let's change this to a translucent fill, just because I do like purple. I'm a K-State person, but for this we want to see through it. Okay. So we got that all set up. So now we're essentially ready to do some analysis on our field. In this case, we're just going to do a Malik 3 part per million extraction from a kriging that we did earlier. So we already have the layer that's made. So you go in here, add raster layer, and go browse for it. See where we got it. Here's the GIS and TIFF file. So again, this is kind of like the shape file. You're going to select the file that says TIF for TIFF, and it's going to automatically link up with everything else that it needs right off the bat. So hit add, and now we got our TIFF file. Now you notice it's not actually clipped to the field boundary. In this case, it really doesn't matter too much. Actually, well, we'll leave it just like that. We do have one hot spot here. There was a 99 part per million that I did suck out when we actually created the recommendation for the farmer, but it was left in during this initial kriging. But let's go ahead and suck out the information that we got in there. So we're essentially going to, let's see here. Where's our TIFF file at? There it is. Let's bring it down. Let's go below the clipped. So essentially we're going to suck out the mean Malik 3 value that we created in a Krieg into each individual cell. Okay, so to do that, we need to come up here and type in zonal statistics. So it's right here underneath the raster analysis button. So what this is going to allow us to do is input a raster layer. So this is going to be our Malik 3 2019. So this is our TIFF file that we added. Defaultly it's going to have one band, which is gray, just because it's not a composite, just one band. And then our vector layer containing our zones. Right now it's just going to extract the mean value to the whole field, which would be useful if you're doing a flat rate. But in this case we already gridded the field out, so why are we going to do a flat rate when we can do variable rate? So let's go ahead and click the clipped. And then the output column prefix. So we're going to name it the M3 AV for average. And statistics to calculate. You can do all sorts of them. Oop, it popped up in a different window. You can do count, sum, mean, median, a bunch of different things. In this case, we're just focused on the mean value for each cell. So we can go ahead and click mean, or leave it the only one highlighted, click OK, and we'll run that. So now what that did is let's go ahead and get rid of our Malik 3 background. Before we do that, let's turn it into a nice, pretty color so everybody can see where our hot spots are. I can break it by 6 colors. Okay, so we can see that over in this corner of the field we have a much higher Malik 3 part per million, and then over in these corners down in this area it's much lower. So essentially it's trending high to low up in these areas with a couple little hot spots in the area. So we'll go ahead and turn that off, and if we go to our clipped and go to our attribute table, we can now see it defaultly when it creates the grid it's going to create an ID, and it's going to create basically all 4 of the corners. So wherever the corners are out of the polygon, it's going to have an XY coordinate. So that can be useful if you're wanting to know where these grids are at in the field. But since it's in a shape file, it's linking up with us. So we don't really need this, but I leave it in there just for safety measures for later on in the future. But we can see here we have our Malik 3 average part per million in all of these cells. So let's see how many cells we have. We have about 6,000 cells out in this field where we extracted the mean phosphorus value. So let's go ahead and display our newly created results to this. So double click on it, and then you're going to come down here and we're do a gradiated symbology, and then we're going to select it to be the Malik 3 average mean, and then the symbol, don't think we need anything for the symbol. We just need it to be this precipitation gradient, and we can classify it. So equal count, equal interval. I think that's what we did last time. Let's just do an equal interval. You can change it. There's all sorts of different ones. Equal count, interval, logarithmic, scale, natural breaks, pretty break, standard deviation, so on. So let's just do 6 classes with the precipitation like gradient. So click apply and OK. And now we can see in our grid cells where our hot spots are at. So it's essentially just like our initial values, only now it's just in a gridded out format, so we can create basically variable rate applications or do statistics on our field or whatever. So if we wanted to create an application map through the grid, that is, we can do this through raster calculator as well, but we'll just do an example through the grid. We can open this up and go to our little edit button and go over here, and we're going to calculate a new field. So create a new field. We're going to name this, what are we doing? Pounds of map application. Pounds of map, let's do it in a decimal number, precision of 0, just round to the nearest whole number. And I've already created a algorithm, or basically just math equation to calculate a build and maintain recommendation if you had 50 pounds that you're removing. So this would be like roughly 180 bushel corn or 100 bushel wheat, something like that. So it's a build and maintain up to 20 part per million, and then it's going to be across 4 years. We're going to come back and do the same application. This removal will change. We'll get into another video on this later. But essentially what's going to do is create a variable rate application and round our recommendation to the nearest 30 pounds of map, just because we can't apply in a rate controller like to the nearest pound. So we can go ahead and put OK. And there we go. We got some rates here. So we can see when our Malik 3 is lower at 7, we're applying 210 pounds of map. And as we go up, let's sort by Malik 3. Okay, there we go. So as we go up, eventually we're a little bit higher in soil test, which is to 180. And then we go up a little farther. There's our new break at 12 part million. Now we're applying 150. 120 at 16, just 90 at 19 to 20, and then we're maintaining all the way through 30 part per million. And once we break 30 part per million, now it is applying nothing. So at 30.01, saying we're above 30 part per million, we're not maintaining our field anymore. It's based off of K-State recommendations, and now we're applying 0. I'll have a whole video on how to create these equations another day. But for today, we're just going to focus on how to display these newly created grid results. So remember always to save your data and then click the Unedit tab. Now everything's saved, and let's see what we popped out. So double click, let's change this to our pounds of map. And we'll classify that. And actually, since we have different rates of it, instead of doing a gradiated type formula, or I guess symbology, we can actually do a categorize. So since we know we have X number of rates out in the field, we don't need to be gradiating it because we've kind of already dumbed it down. So we can do a classify or a categorize in this case. So we can classify that. I don't know why it always does all other numbers here, even though there aren't any, so you can just unclick that and hit apply and OK. So here, let's get rid of some of this extra blurb, and we can see here's our new application. So that's a fun application of 90 pounds just out in the middle of nowhere. There must be a grid point right on top of there, but anyway, so there's our newly created application map. So we can see where we were lower in phosphorus, which is up in this corner. We're actually applying more phosphorus over there, or MAP fertilizer, I should say. And then when we're higher, we're actually applying nothing over in this area. So I'm pretty sure that that is a grid point. In fact, just for the fun of it, let's add in the grid points. Yeah, so there's a grid point nearby right there. And again, there's a grid point right there. So there is a couple spikes out in the field, but nothing too bad. It's overall a pretty good map. Honestly, a grid size of 20 foot by 36 foot or 27 foot by 36 is a little bit small in most cases. I think the smallest I would probably go is like 50 foot by 50 foot, just because your combine headers are not, you're going to be like right at a combine header width. So unless you're interpolating things really well, you may not be able to manage things down to this small of a grid that we see out here. But it does make a nicer looking map in the end. So that's pretty much how you would suck in data into the grid. So like I said, you could do this to interpolated yield data, and then instead of creating you could create a nice little pretty map of it, but you can also look at each grid cell from year to year and see how it changes, and then make recommendations to your particular farm or field based off of that. So I think I kind of covered most of what I wanted to in this video. So yeah, with that, I think we pretty much hit everything. So I don't know what the next video will be. I need to come up with some new things. If you have any questions, or if you'd like a request a video, feel free to comment below, and we will continue on with our QGIS tutorials. So we'll catch you next time.